All right, hey, how you doing? Um, Welcome back to my channel. I don't know if I can say back because I don't know how many people have been here, but yeah, just welcome back. It's Martin Luther King Day. Happy Martin Luther King Day to you. And if you don't know who Martin Luther King is and you're living in America, shame on you. Hashtag Team Aquarius Martin Luther King. I digress. Anyway, so today, or any day, we're going to be talking about how to study for physics using these cards and the tips and tricks I use to study. So I'm just going to go over these mathematical constants. So one of the things I like to do is I like to have these flash note cards and that right there. And so basically what you do is you take your mathematical constant, or you take your mathematical constant. Check it. You write 0. The first one is 0, and basically you write the definition down. So what I have a lot of time like if you're struggling with math, or maybe certain things like the constants don't make sense, this is one of the great ways to do it. You write down the definition on the back, and I also write down an equation or formula for what it can mean, and then I also wrote the root of what it means also on the back. So this is not a particularly good example because for the formula I have for 0 is 0 plus 0 equals 0. So that's pretty much it. And then, but if you do you take your first part of it, label it, and then at the bottom you're gonna write the word out, and then you're going to write it in its numerical form if it has a numerical form. If it doesn't, then you just move on. I think I got mu or phi. They most usually have a numerical form, or sometimes they don't have a symbol. Sometimes the symbol is the mathematical constant, so you just got to move past that. And like I said, you just put the definition where it came from, like the root of where it comes from, because I like to learn the history of things. I'm just that person, and I want to know where did it get its start. And so I'm just gonna go over what mathematical constant means, because so let's talk about constants. So my post-it card says a constant is a special number that is special in some way. They are diverse in context in geometry, number theory, and calculus. They arrive naturally, intrinsic math nature, and they are definable numbers. So these are numbers that are usually numbers we see that continue to pop up, that are very useful for us to use in our mathematics. I am a very good person at moving past constants. I can work around constants because I don't find them necessary to use them all the time. So I'm going to tell you, I'm going to go through each of my constants that I have, and then we're going to talk about my issues that I have with certain constants. And I didn't write down all the constants, but these are like the main constants. Anyone that has done science or mathematics would know, even regular people. So the first one is 0. I love 0 to death. I think 0 is the best thing. 0 times 0 equals 0. 0 plus a number equals a number. 0 divided by 1 is undefined. It's pretty much, is that a smell? No, it's not. It's pretty much it. Like 0 is the best. You gotta love 0. If you don't love 0, then just kill yourself. 1 means unity and a single entity of counting, single unit measurement, infinite series of natural numbers after 2, 1, and it's a rational number, and it has like the roots with the number 1. Obviously it has roots with the abacus, which numbers have in general. So you count 1 by 1, and I think that's like one of the best ways to think of the number 1 is you want to think of how like there's one portion at a time. I like to visualize my mathematics, so that's like what I'm getting to at the moment when I go like 1, 2, and there's no reason to go 1, 2, 1, 2, 3 or anything, obviously, because we have so much entity, so much matter of anything. You're not gonna just have like 1, 2, 3, 4. You understand what I'm trying to say? You understand what I'm trying to get across? I hope so. Imaginary unit I, aka the square root of -1. And so what this is imaginary unit is the solution for a quadratic equation. For example, x squared plus 1 equals 0. It's commonly used to denote electric current. The two main complex square roots are -1, just as 2 square roots of every real number other than 0 has double square root. I squared equals -1. Now that may have not made sense to you. I keep this one. I'll even use I, and mathematically I don't see it. Like when I just see it by itself, I don't see it in my brain. But if I like try to do it like algebraically, if I set up an algebraic equation right there, I can actually see it. So I wouldn't understand what it necessarily represented in the real world, but you know, imaginary units. Pi. If this isn't the most overrated constant in the universe, and when you go to do your physics homework, they like for the solutions on how to use for using pies, or for, you know, how they tell you how to do it, they put pi freaking everywhere. Like, grow the fuck up. Like, if you travel in a straight line on a circle, why the hell do you need pi? We're on a circle, traveling the line to the point where you're going. I actually get marks on my homework because I will take pi out of the equation. I'll find a way to work around pi. It doesn't make sense to use it. It's a one-dimensional it's a one-dimensional, it's just a basic unit. You're not supposed to be using it everywhere. You're not. Makes me mad. Makes me even madder when I get in trouble for taking it out. Euler's number. This one's really useful. Euler's number, it pops up naturally, and the equation behind it is 1 plus 1 over n to the n. It's a base natural logarithm with each ratio equals to 1. So that's just like kind of saying, like, it has a beat and it goes like 1, 2, 3, 4, 5, or maybe like the natural logarithm, like I would be like 1, 1, 1, 1. That's what, you know, I'm trying to convey, but that's basically how it would be. That's how. Am I musically transpiring mathematics? That's weird. So yeah, it's Euler's identity, and it's really like useful. I find it the most useful when you're talking about like thermodynamics, and that's like one of the places I like to use it. I still can work around it. I just don't hate it as much as I hate pi. There's no reason to use pi. The square root of 2, Pythagoras constant. The square root of 2 is the square root of 2, or you could write it 2 to the 1.5, which is probably something I would do. Or you can write 99 over 70. Yeah. 1.14. And I have a little chart back here that kind of shows how, like, how it proves it. And those are different ways to prove it. Like, you got different ways. Like, I just proved it like mathematically, like a logarithm, because it's a rhythm. But yeah, and I mean, there's no reason. You use it when you use it, and that's pretty much it. The square root of 3, Theodorus constant, which I didn't finish the word out, and this is the square root of 3. The square root of 3, approximately 1.73, and also rather known as 97 over 56. And I'm going to do a separate video about fractions, because I prefer fractions above all. I've always been really good at fractions and percentages. So I'm going to do something separate with that, and we'll talk about it and maybe be friends about it. The square root of 5, it's a positive real number. It's approximately equal to 2.23. It has its own principle of square roots. It appears in the fractional expression of the golden ratio, and it's noted in third form as the square root of -5. It's also irrational. But anytime you see like a square root of a number that can't be necessarily squared, then it's irrational. So the Euler-Mascheroni constant, and honestly I don't know this one. I don't know it, and yeah, I didn't finish the card. I didn't. So, but I probably used it before, and I probably used it before. I just don't remember where. That's why it's good to keep a log of everything. If you wake up in the morning and just kind of go over those each morning and refresh your memory, then they can start being like integrated, a part of you, a part of your system, a part of like how your everyday life and everything, how you're breathing. and try to visualize mathematics as one of the things. And I think I'll put that in a separate video because I think that's like a good design for like basically learning math. And thanks again. Like, subscribe and share this video because it's really hard out there for a pimp, and I'm trying to make it, so do the thing for me. Thank you.